We are going to look at concentrations as far as conceptually understanding them. If I have my drink mix here, and I just put a little solute into my solvent, I might think that this is a pretty strong concentration. I didn't have too much, but I also have a pretty low amount of liquid. However, so let's say that I add even more. Notice that my color got quite darker, and I even have some grittiness in the bottom where it's not dissolving. So at this point, I would say I have a saturated solution. I have my maximum possible solute in solution volume. Actually, it's to the point where it's almost what's called super saturated, where it won't even dissolve. So right now I have a very high solute to solution volume ratio. It's very concentrated. But what if I were to take this and pour it into another glass? Oh. So now we can see that I have diluted this solution, and I now can say that I have a low solute to solution volume ratio. We can see that it is a much lighter color, and if we were to look at that amount of, if I were to measure how much solute was in this that actually ended up being in this solution, it would be a much smaller ratio. Next, we have here a simulation that I want you to check out on the PhET simulations page. So let's say I've got this container here with my solvent, my water, and let's say I add a little bit of solute over here. Right now it's at none. So let's add a little drink mix to this, and notice that it's similar to that Gatorade powder that I was putting in. If I just put a little bit in, we can see I have over here we can see my solution concentration. It's pretty low. It's not zero. It obviously would be zero if I had no solute in there. I would have zero concentration. So notice the relationship when I add solute to my solvent. When I add just a little bit, I have low solution concentration. So as you can see, the relationship as I add more solute, my concentration gets higher, and we can see this, that the color gets darker, but we would also know by the taste, right? The taste isn't going to be so, well, maybe you like dilute concentrations, but it would taste really, I guess, watery. I don't like really dilute, but I also don't like the really concentrated. I actually don't even like regular Gatorade. I like that G2 or Gatorade Zero. It just tastes too sugary and processed. As you can see, that is one way to increase and decrease the concentration, is by controlling that amount of solute. Similar to what I showed you with my very concentrated little bit of drink mix that I had, we can change the amount of solution. So let's say I had a very concentrated drink mix here, but if I add more water, if I add more of that solvent, notice what happens to my concentration on the right. If I add more solvent, notice what's happening to my concentration over here. If I add more and more and more, it becomes less concentrated. And we can see that it becomes lighter if I, compared to where I started, which was a very dark and very concentrated solution mix. The other one I wanted to show you is this one. Similar, but we can see that we can change here I go, I've got a half a liter. So I shake this drink mix here, and we can see that I can measure my concentration. I'm going to add more. And we can see the more I add, my concentration increases. Add more, and we can also see that it's getting darker. And at this point, I have a saturated solution. All of the solute that's been added in there has been dissolved. That can be, to the point where now, see, I add, and it makes it's grainy at the bottom because it cannot absorb anymore. So let's try doing this. Okay, starting back over from 0. So notice let's get my concentration up just a bit. Now what's going to happen when I turn on the water? Notice what happens to my concentration. 1.38, let's add a little bit more water. 1.25, so my concentration goes down when I add more water. Again, I can increase my concentration by adding more solute. Let's get to the point of another high concentration. Notice it's getting darker. We can see my concentration's really getting up there. Let's try to get it saturated again. Okay, we're at the point where it cannot absorb anymore. We're saturated, almost 6, 5.96. Let's see how, notice I add more water, and notice that that water is mixing in with my solute. Look at concentration still the same until I get everything until it's not saturated anymore. That concentration stays the same. Oh, and now my concentration goes down. Some examples of saturated solutions, or just solutions in general, would be brine. If you've ever brined a turkey, this is just kind of a picture kind of showing you take 2 cups of water for every 1 cup of salt, and you stir and you dissolve it, and you add in your different herbs and spices, and then you add whatever, your chicken, turkey, your pork, your shrimp, whatever it is that you want to brine. Also very common for making pickles or pickling something. This would be a saturated solution, the solution that contains the maximum amount of solute. Another example is making orange juice. So using orange juice concentrate to make this orange juice solution. You do this right on the little container. If you've ever done this, it says you take 1 can of this concentrate and you add 3 cans of water. So 1 and then 3 cans of water. When we do that, we then have 4 total cans of liquid. So this is called a 4-fold dilution. Yes, we've only added 3 cans of water, but remember we have to include that 1 can of concentrate. So that means that there's 1 unit of concentrated, 4 total units. So 1 plus the 3 cups of water, so 1 concentrate for 4 total units with that final diluted solution. So that's a 4-fold solution. Another common dilution ratio is called a 10-fold dilution. So I would have 1 concentrated and then 9 solvents. So I'm going to do this. 1 concentrated and 9 solvents. So a total of 10. So this would then be written like this. So it's 1 concentrated with 9 solvents, also written 1 concentrated to 10 total in solution. For example, if I had 5 milliliters of concentrated apple juice and then added 9 times 5 is 45. So so if I took a 5 milliliter, let's say pipette, or 5 milliliter little cup, whatever it is. If I took 5, then I would take, so that would be 1 serving of that, and then 9 more of that. 9 times 5 would be 45 milliliters of water. So I would have 45 of water, 5 concentrate, so that's a total of 50 milliliters total. So I would then write it like this on the screen. 5 mils concentrated with 45 mils of water, so that's a 1 to 9, which means my total diluted solution is adding these two together. So 1 and 9 would be 10. Here we've got 5 and 45 to equal 50. 5 ml concentrated to 50 milliliters total dilute solution. That would be a 10-fold dilution. And that's often used, especially when you get to microbiology or the other biologies or even in the healthcare classes.